Validating webhooks are a powerful mechanism in Kubernetes that allow you to enforce custom policies and security rules across your cluster. They act as gatekeepers, ensuring that only compliant resources are allowed into your Kubernetes environment. Throughout this tutorial, we'll explore how validating webhooks work and how to implement them effectively to maintain cluster security and compliance. Validating webhooks are HTTP callbacks that intercept requests to the Kubernetes API server before objects are persisted to etc. Think of them as security checkpoints that examine every resource creation or modification request. They have the power to allow or deny these requests based on custom policies that go beyond Kubernetes' built-in validation. Importantly, these webhooks run after authentication and authorization phases, meaning the user has already been identified and granted permission, but the webhook ensures the request meets your organization's specific policy requirements. To understand where validating webhooks fit, let's look at the complete admission control flow in Kubernetes. When a request reaches the API server, it first goes through authentication, where the system verifies the identity of the requester. Next comes authorization, which checks if the authenticated user has permission to perform the requested action. Then comes the admission phase, where our validating webhooks enforce custom policies. Only after passing all these checks is the resource finally persisted to etc., the Kubernetes data store. This multi-layered approach ensures comprehensive security and compliance. To set up a validating webhook, you need to create a validating webhook configuration resource. This configuration uses the API version AdmissionRegistration.k8s.io/v1. The metadata section gives your webhook a name, such as policy-webhook. The webhooks array defines the actual webhook configurations. Each webhook has a name, like validate.example.com, and a client config section that tells Kubernetes where to send admission requests. This typically points to a service running in your cluster, specifying both the service name and namespace where your webhook server is deployed. The rules section is where you specify exactly what resources and operations your webhook should intercept. The operations field defines which actions trigger the webhook, such as create and update. You can specify which API groups to monitor using API groups, with an empty string representing the core API group. The API versions field indicates which API versions to validate, and the resources field lists the specific resource types, like pods. Additionally, you must specify which AdmissionReview versions your webhook supports, typically v1. The side effects field should be set to none if your webhook doesn't make changes outside the admission request, and timeout seconds defines how long Kubernetes should wait for a response, commonly set to 10 seconds. When Kubernetes sends an admission request to your webhook server, the server must respond with an AdmissionReview object. This response uses the API version admission.k8s.io/v1 and has a kind of admission review. The response section is critical. It must include the UID from the original request for correlation purposes. The allowed field is a Boolean that determines whether the request should proceed, set to true to allow or false to deny. When denying a request, you should include a status section with a message explaining why the policy was violated. This message is returned to the user, helping them understand what needs to be corrected. Validating webhooks can enforce a wide variety of policies to improve security and standardization. Common examples include requiring specific labels or annotations on all resources, which helps with organization and automation. You can block privileged containers to prevent security risks. Enforcing resource limits and requests ensures fair resource allocation and prevents any single workload from consuming excessive cluster resources. Another popular policy is validating image registry sources, ensuring that only approved container images from trusted registries are deployed in your cluster. These are just a few examples of the many policies you can implement. One critical configuration decision is choosing a failure policy for your webhook. This determines what happens if your webhook server is unavailable or fails to respond. There are two options. The fail policy blocks requests if the webhook is unavailable, providing maximum security by ensuring no unvalidated resources enter the cluster. However, this means your webhook becomes a critical component, and its unavailability can block legitimate operations. The ignore policy allows requests to proceed if the webhook fails, prioritizing cluster availability over strict policy enforcement. This is useful during initial webhook deployment or for non-critical policies, but it does create a window where policy violations could slip through. When implementing validating webhooks, follow these best practices for reliability and security. Always use TLS for secure communication between Kubernetes and your webhook server, protecting against man-in-the-middle attacks. Set appropriate timeout values that balance thoroughness with performance, typically between 5 and 10 seconds. Implement proper error handling in your webhook server to provide clear, actionable feedback when requests are denied. Use namespace selector to limit the scope of your webhook, avoiding unnecessary overhead by only validating resources in specific namespaces. This also prevents potential issues where the webhook might interfere with system namespaces or its own deployment. Let's recap the essential concepts. Validating webhooks enforce custom policies before resources are persisted to etc., giving you fine-grained control over what enters your cluster. You must carefully configure rules, timeout values, and failure behavior to balance security with availability. Most importantly, validating webhooks are essential for cluster security and compliance, allowing you to enforce organizational policies that go beyond Kubernetes' built-in validation. By mastering validating webhooks, you gain a powerful tool for maintaining a secure, compliant, and well-organized Kubernetes environment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.